Hi. Now in the last part of this question then, we're given that we have a curve C, and the equation of the curve then is y equals the square root of 4x plus 1, where x is greater than minus quarter and y is greater than 0. And we've got to find the equation of the tangent then at the point where x is 2 on this curve. Well, first of all, what I'm going to do is sketch the curve. You could do this problem without sketching the curve, but I do feel if you can sketch it, it does give you some appreciation of what's going on. So we'll start off then by drawing our axes. Now we've got a y-axis then and an x-axis, so mark those on. And if you were to sketch this curve, what it would look like is something like this. Part of a curve going like this. When x is minus a quarter, you end up with 0 here, and you've got the square root of 0, which is 0. And then as you put other values greater than minus a quarter into that square root, okay, normally you would get plus or minus when you square root values, but we're only looking at the positive y values, so you're going to get this part of the curve. If it was plus or minus y values, your curve would look something like this. A parabola on its side. Okay, well, we're looking at the point P on this curve where the x coordinate is 2. So let's suppose that that point was up here. Okay, we'll just label that P there. We know its x coordinate is 2. We're looking for the y coordinate. I'll just put that in as y for the moment. But at this point we've got a tangent to the curve, so let's just draw that tangent in. Let's say we draw it in green. So it's going to be a line coming along like this, something like that, okay? Now, if we've got to find the equation of this tangent, then being a line, the equation of any line is going to have the form y minus y1 equals m bracket x minus x1. I prefer this form rather than y equals mx plus c because it's so quick to find out the equation of the line. You don't have to go out and find out what c is, this point here where the line cuts the y-axis. x1, y1, remember, is a point on the line, and we're going to use this point P here. We know what the x1 coordinate is, it's 2. We don't know what the y1 coordinate is yet. Okay, we'll do that in a moment. And we're also going to have to find out m, the gradient. So, how are we going to find out the y1 coordinate? Well, that's dead easy. All you've got to do is substitute x equals 2 into here. So let's start by doing that, okay? So we can just say that when x equals 2, what have we got for y? Well, we've got y equals the square root then of 4 times 2, which is 8, plus 1 is 9, so we've got the square root of 9. And we know that that's got to be equal to 3. Alright, because y's got to be greater than 0. So I could replace this value of y then with a 3. So we'll just do that. So we now know the coordinates of P. We've got our x1, we've got our y1. What we haven't got is m, the gradient. How do we get the gradient? Well, when you're looking at a point on a curve, then you need to differentiate the equation of your curve, which was c, by the way. Just put that in there. Okay, so we need to differentiate y with respect to x. So I'm just going to say also, let's prepare this ready for differentiation. This square root, we can change that to y equals 4x plus 1 all to the power a half. Okay, if it was the cube root, it'd be to the power third and so on. Now to differentiate this with respect to x, we need to use the chain rule. In the previous parts of this question, I demonstrated how to use the chain rule. If you're still unfamiliar with this, then just go on my website, look under chain rule, and hopefully you'll see examples of differentiating functions like this. So, to differentiate this by the chain rule, I call 4x plus 1 t, and I say this is t to the power half. Differentiate t to the power half, and you've got half t to the minus a half, t being the 4x plus 1, and it's to the minus a half. Now I have to multiply it by dt by dx, in other words, times it by the differential of 4x plus 1, which would be just simply 4. So what have I got here? If I tidy this up, well, half of 4 is 2, and I can think of this as 2 times 1 over 4x plus 1 to the power a half. So we can bring that in underneath here as 4x plus 1 to the power half. Alright? So I need to get the particular gradient at this point. Remember, this is the general gradient at any point x on the curve. So I need to say that when x is 2, that point here, we can substitute 2 into here, and we can therefore have that dy by dx, the gradient m, is equal to 2 divided by, and we know that this would be the square root of 9, which is 3. So the gradient at p is 2/3. So where does this leave us now? Well, it just means that we can find the equation of the tangent. Okay, so I'm just going to write a short intro here, and I can say that therefore equation of tangent, and I'd always recommend that you do this, okay, rather than just stepping straight into the equation. Just give the examiner or whoever's reading it some idea of what's going on, and so we can say the equation of the tangent at P is, and what is it going to be? Well, using this format, it's going to be y minus y1, y1 is now the 3, equals m being 2/3, x minus x1 being the 2. Now unfortunately it doesn't stop there, because we've been asked to give this in the form ax plus by plus c equals 0, where a, b and c are integers, okay, whole numbers. So what would I want to do? I'd want to times both sides by 3. So if I do that, I'm going to get 3y here minus 3 times 3, which is 9, whoops, writing a 3 there, minus 9 equals, and then I'd want to multiply all of this by 3. So if I was to multiply this by 3, the 3 would get cancelled and just leave me with 2 bracket x minus 2. So I'm going to expand that and get 2x minus 4. So to get into the form ax plus by plus c equals 0, I'm going to see that this is a positive term. I'm going to subtract 3y and add 9 to both sides. So if I do that, I'm going to get 2x, then minus 3y, add 9 to the minus 4, and that's going to give me plus 5, and that's going to equal 0. So I've got it in the form now, ax plus by plus c equals 0. If we were ever asked to state the values of a, b and c, a would be 2, b would be minus 3, and c would be 5. But we're not, so there you go. That's the answer to this part of the question. That brings us now to the end of the whole question.